Welcome to today's lesson on basic introduction to alkanes, the ultimate couch potatoes of the chemistry world. That's basically how I refer to alkanes, the couch potatoes of the chemistry world. These guys are so cool and chill that they don't even react that much. And if alkanes were humans, then they would be the ones sitting on the couch watching Netflix, ignoring all their responsibilities. Very much unconcerned about life and straightforward and taking everything simple in life. That is alkanes for you. But what exactly are alkanes in the world of chemistry? Just imagine a bunch of atoms holding hands in a straight chain. So if this is carbon, bunch of carbon atoms holding hands in a straight chain. And each of these carbon atom has all its free hands grabbing onto hydrogen atom like a toddler grabbing candy. So the free hands are holding on hydrogen atoms. This is what we call an alkane. So this is one example of an alkane. It's a hydrocarbon, meaning it's made up of hydrogen and carbon only. So if this is carbon, then this is hydrogen. And these are the only two elements present in alkane. Alkanes are also known as saturated hydrocarbons. And what that means is that all the carbon atoms present in alkanes have only single bonds between them. No double bond or triple bond found anywhere. And it's saturated with hydrogen atoms all around. So saturated hydrocarbons, which are alkanes, have only single bonds everywhere in their molecules. And we can think of alkane as the simplest, most boring hydrocarbon we could ever meet. They are like the plain cheese pieces of the chemistry world. No toppings, just cheese. Now for functional groups, alkanes do not have any functional group present in their molecule. So that's very outstanding. No functional group. And it's like they go into a party without a costume. No double bond present in them. Neither do they have any triple bond present anywhere. So that's quite significant. No double bond, no triple bonds. And interestingly, they also do not have any carbon-oxygen bond or oxygen-hydrogen bond present in their molecule. Only single bonds throughout. And they are okay with life. Very, very simple and content with what they have. Now we will move on with the general formula of alkanes. For the general formula for alkane is CnH2n plus 2. So the general formula is more like the secret recipe for making the alkane molecule. And this recipe is just like our grandmother's secret cookies recipe that never fails. And in this formula, the N here stands for the number of carbon atoms present. And then you double the number of carbon atoms present and add 2 to it, and that gives you the number of hydrogen atoms that should be present in the molecule. So imagine N as the number of seats at a dinner table, and for every carbon guest there is always 2 hydrogen party crashes who bring up extra 2 friends along. So that's basically what the general formula is. But how the question now is, how does this general formula actually help us to get the molecular formula of the alkane molecules? So we'll look at this table and we'll do some few calculations out there. This is the general formula, and we are going to do some few calculations here and there. Now we said earlier that the N stands for a number of carbon atoms present. So if the carbon atoms present are 3, so that means carbon will be 3, and the hydrogen atoms will be 2 times 3 plus 2, and that will give us 8. An interesting recipe from our grandmother. And if we are able to use this formula, I tell you, you'll be able to write the molecular formula of any organic compound, specifically alkanes. If the carbon atoms are 5, C becomes 5 and H becomes 12. And try to figure out how we got this calculation. And then what that means is that the molecular formula will be C5H12. Now pause the video at this point after we've done a calculation for carbon number 3 and 5 and try to see if you're able to guess the molecular formula for the alkane if the number of carbons are 6. Remember to use this formula, CnH2n plus 2. Just follow the first two strategies we used and you should be able to get the molecular formula. After you are done calculating the molecular formula, move to the comment section and write down the answer you've gotten. Alkanes belong to this fancy club called the Homologous series, and basically this Homologous series is more like a secret society where everyone wears the same outfits but in different sizes. And when we say the same outfits, we are referring to them the general formula. So they use the same general formula, but after applying the general formula on each of them, you realize that their outfits are slightly different from each other, and each alkane is just a slightly taller version of the one before it. And the first member of this homologous series of alkane is methane, CH4, and the second bond after the methane is C2H6, and each member differ from the one before it by a CH2 unit, CH2. So the difference between methane, the baby of the group, and ethane is CH2. How do we get the CH2? If you think this, the C here is 1 and the C here is 2. So if we subtract 1 from 2, we have 1. And this side, the H is 6. The H is 4. If you subtract 4 from 6, we are going to get actually 2. So the same thing applies to this and this. So what that means is that by just keeping this unit in mind, we'll be able to tell the next member in the homologous series. So if the number of carbons is 5, what that means is that we are going to add CH2 to this one, and we'll get the molecular formula for carbon number 5, and that will be C5H12. So pause the video and write the molecular formula for the situation where the number of carbons, we have 6 carbons in there, or the number of carbons are 6. So this homologous series are just like Russian nesting dolls. This Russian nesting dolls, each one is just a bigger version, but still pretty much the same as the one before it. Let's move on to the physical properties of alkanes. For the state of matter of alkanes, alkane number 1 to 4, that is methane, ethane, propane, and butane, are gases at room temperature, and they are the life of the camping trip. As the number of chains increases from 5 to 18, alkanes now become liquids, and from 18 above they become solids. So that's basically the state of matter of the alkanes, and they are basically colorless in their pure state, and they are also insoluble in water. So alkanes are actually non-polar, meaning they are hydrophobic. They do not actually mix well with water. The relationship between alkanes and water is just like the one between cats and dogs. They just don't get along very well. But alkanes are actually soluble in organic solvents like benzene and ether. So in fact, we can say that alkanes are so non-polar that they would actually probably like to skip any chemistry class just to avoid getting into any polar situation. So these are the few physical properties of alkanes. What about the chemical properties of alkanes? You know, alkanes are actually the calm, collected members of the hydrocarbon family. They are like that student who sits quietly in class, minding their own business and avoiding trouble. But if you put them in the right environment, they can still make some noise. That's how alkanes behave. So the first chemical property of alkane in this situation, combustion. So alkanes are like the shy kids who sadly becomes the life of the party when you least expect it. And when alkanes are ignited in oxygen, They burn like a bright flame, producing carbon dioxide and water. So that is basically what combustion is all about. So it's like the chemical equivalent of turning up the volume. Alkanes actually release a lot of energy, making them great fuels. So that's one chemical property of alkane. And the next chemical property we'll talk about is substitution reactions. So alkanes can actually undergo substitution reaction. So alkanes are not that big on reactions, but they do have this go-to reaction, which is the substitution reaction. In the presence of ultraviolet light, alkanes can replace one of the hydrogen atoms with a halogen, like chlorine or bromine. And this is more like swapping one team member out without changing the overall strategy. And when we get to reactions of these alkanes, we'll actually talk about substitution reaction more into details. Now we'll take a look at some uses of a few selected alkanes. The first one is methane. Methane is actually the superstar of natural gases and it's used for heating, electricity generation, and as a precursor to various chemicals. And the next alkane is propane. Propane is actually very good when it comes to fuels. So it's a go-to fuel for barbecues, camping stoves, and even forklifts. So propane tanks are like the life of the outdoor parties, keeping the burgers you have flipping and the marshmallows roasting. So without propane, your summer workout would be a lot less fun. Another examples of alkanes that are so useful to us are butane, pentane, and hexane. But I'm going to leave that for you to look for their uses. So look for the uses of butane, pentane, and hexane, and write what you find in the comment section so we'll all learn from that. So some fun facts and comic relief about alkanes is that alkanes are like those quiet kids in class. You might not notice them at first, but they got all the answers when it counts. And alkanes are like the chemistry versions of Switzerland. If you pay close attention to everything we've done so far, you realize that alkanes are actually neutral, unreactive, and just happy to stay out of conflict, just like Switzerland. So alkanes behave just like that. So in conclusion, alkanes are the reliable straight-laced hydrocarbons that form the foundation of organic chemistry. Whether they are heating your homes, powering your grills, or keeping your lighter in actions, alkanes are always there quietly doing their job. They might not be as flashy as alkenes and alkynes, but actually without them the world would be a much colder place. Yeah, literally. So the next time you strike a match, light a grill, or even enjoy a toasty winter night, give a nod to the alkanes, the unsung heroes who keep the world running smoothly, one single bond at a time. So this brings us to the end of this lesson on alkanes. The next lesson after this is naming of alkanes, nomenclature of alkanes. If you find this lesson helpful, beneficial, interesting, then consider liking and sharing. And also subscribe to the channel to help us grow. If you have any concerns or any questions or ideas for future episodes, you can actually leave them in the comment section. See you next time.